provided we will resolve a function by math calculation. In the same way, to undertake calculation and procedure required to obtain the vertical and horizontal asymptotes, domain, range, restriction, and it will make use of high order derivate for derivatives and apply evidence as the ID test and concavity. So here is the point A, and we're going to find the restriction and the domain of the function. Here is the function that is x over x squared minus 1. And to find the restriction, we have to isolate the x. And here is the procedure. And x can be 1 and x can be minus 1. So the domain is all the real numbers except 1 and minus 1.
Gina.
So here is the point B, and here we are going to find the x and the y-intercept. For the x-intercept, you have to equal the function to 0, and then we have that the intercept in x is 0, 0, and the y-intercept, you have to, the x is equal to 0, so you make the procedure, and the intercept in y is 0, 0.
Well, to find the symmetry, you have to evaluate the function in minus x. Therefore, you have to substitute the x by minus x in the function, and you obtain the result is minus x divided by x squared minus 1. So this is an odd symmetry because you have a different sign between the function. So when you have a different sign, it is an odd symmetry. Well, to obtain the vertical asymptotes, we have to know, we first have to know the restrictions. So in order to obtain the restriction, we have to factorize the denominator of the function. And we obtain that the restriction is x can be 1 and minus 1. So in order, we have to, when we have in the function, we can observe that they can simplify with the numerator of the function, and so in order of that conclusion, we can say that there is no gaps in the function.
Here we try to obtain the horizontal asymptote, and when limit it's x tends to infinity. We have x over x squared minus 1, so we divide with the x with the higher exponent, which is x squared. So we divide x over x squared over x squared over x squared minus 1 over x squared, which is equal to 1 over x squared over 1 minus 1 over x squared. Then we substitute with the infinity, and we have 1 over infinity over 1 minus 1 over infinity, which becomes 0 over 1 minus 0, which is equal to 0, and then we have y equals 0. And in here, we do exactly the same thing, but when x tends to minus infinity. So we'll divide again with x squared, and this is our result. And then we substitute with minus infinity. And in here, minus minus is equal to plus. And 0 over 1 plus 0 equals 0. So we have again y equals 0. So this is our function, and to have the first derivative, we have to use the Gaussian rule. Here we use the Gaussian rule and we simplify it. And it's x squared minus 2x squared equals minus x squared minus 1 and g of x squared.
So here we have the rational ID test. So in here we use the vertical asymptotes to find the behavior. Here we have the asymptotes that is x equal 1 and x equal minus 1. Here is the behavior, and we conclude that the limit when x approaches 1 doesn't exist, and the limit when x approaches minus 1, it doesn't exist. So, and in here we have the t-chart that this only applies for polynomial functions. Here we have the first derivative of the function, that is f prime of x is equal to minus x squared minus 1 over x squared minus 1, and all of this is squared to square. And in here we have to isolate x, and here's the procedure. And at the end we have that x is equal to a square root of minus 1, that is imaginary. And in here we don't have teacher, because we can have a square root of a negative number.
And to have the second derivative, we use the same the derivative we had before. We use it, and we also need to use the quotient rule. So in here, we need to multiply this times this, and then this times this, and this is our quotient rule. We solve it, and then we eliminate these two, and this is our final result.
Here we have the concavity test. Here we have the interval, that is the minus infinito to infinite. We have the test value, the sign of when the function are in minus infinito and infinite, the concavity when it's minus infinite and infinite, and the inflection point. Well, to finalize this project, we can conclude that this is a rational function that is not defined in 1 and negative 1, has not a t-chart in the ID test, and has the coordinates at the origin. We can conclude that the concavity, when the interval is minus infinite to 0, is negative concavity, and when the interval is 0 to positive infinity is just a positive concavity.